since I don't see anybody complaining, I'll assume you all can. All right, well, this is welcome to Hacking the OWASP Top 10, also known as an introduction to application hacking. For those of you who don't know me, here's, sort of a bio, if you will, nothing particularly exciting on it. I will say this presentation is oriented for beginners. If you have a background in application hacking, you could probably give this presentation better than I can. It's, lots more information is available in the reference notes at the end of the slide. I'm not going to go through everything here. This is, like I said, just an introduction, kind of a, wet your whistle, if you will. I do have Discord up, so if you want to type in questions as I'm talking, feel free. I'll keep an eye on it. Now for some disclaimers. Of course, we always have to have disclaimers in this. This presentation is my opinion only, has nothing to do with my employer or anybody saying. Each one of these slides I'm going to go through is a presentation itself. I mean, I talk about, in the very first slide, I talk about injections. Literally, you could have a day class on that. So like I said, this is just sort of to get your feet wet. I may be using some terms in here that are unfamiliar to some of you, especially if you are new to the industry or into application hacking. Most of these things are discussed in the slides at the end. But once again, ask a question and I'll see what I can do about answering it. For those of you that are hoping to see dirty laundry from a company or from a website, sorry, you're not going to see any of that. Would not be responsible disclosure on my side, but you will hear some stories. You're also only going to get pictures. There's nothing live in here, primarily because I tend to have really bad success with live stuff. And like I said, you don't have the time to sit and watch me type these things in real life anyway. I'm also not going to talk about how to avoid and fix these. That's a completely different training presentation for that. So with that, if you are getting into this or interested in getting into this, you might want to know, well, heck, where do I start? Well, there's hundreds of programming languages and millions of computer programs. There's like billions of things with computer programs running on them. So you've got plenty of things to aim at. The other really good news is everything you need is already there. Like I have on the screen for this, I just used a handful of real simple tools, all of which you can download. Now, people have different opinions on this, depending upon who you talk to. Some like Kali, some like Parrot, some like Pentoo, some like Windows. Again, it doesn't really matter. You can do this, sort of application hacking with just about anything. Get yourself some starting tools, Burp Suite, Nmap, the OWASP Z attack proxy. There's Metasploit, and again, all these terms, if they're unfamiliar to you, you can take a look at the slides. I'm happy to send them to whoever's interested. All this information, URLs, all that sort of great stuff is also in this. However, probably the most important thing for a beginner to download and start playing with is a product or a program called WebGoat. It's from OWASP. You're going to hear me talk a lot about OWASP today. It is a worldwide not-for-profit organization that basically does everything around application security. They have their top 10 lists, which in this case is the top 10 most frequently encountered web application security risks. They interviewed hundreds and hundreds of these and put together a list, and that's the list that I'm going to use and show you how you can hack the most common vulnerabilities out there. Another way of looking at it is this is how you can test your skills without being visited by the FBI, which is usually a good thing. Again, here's the information if you want to download it and run it yourself. If you want to do application hacking, you're going to need to learn some stuff. You're going to need to learn programming languages and operating systems. Do you need to learn all this stuff at once? No. Do you even need to learn this stuff? You can argue either way on this, but I look at it as if you don't have a background in this sort of stuff, it's just like not knowing how a computer works. You can still hack it, but knowing how a computer works, how networks are hooked up, the protocols that go across it, all this sort of stuff makes you a better hacker. It gives you more capabilities. And when it comes to programs, if you know how the programming language works, then you understand how the code works. If you're familiar with a couple of frameworks, you know how these programs and applications are cobbled together to make a system. And yes, they are cobbled together to make a system. If you understand the protocols, then you can kind of pick and choose. You can see, well, FTP does things this way, so maybe if I try it in this fashion over here, I can get some information. So, the more you know, the better. Um, so with that, I will get into the actual most frequently encountered web security, which is called an injection. Now, at the very beginning of all these slides, I have my definition of that, which input that causes unexpected behavior. OWASP has another much more wordy version of that. If you're interested, you can take a look at this. But basically what this is this is the equivalent of a username and password. And, I put in, a username of Smith quote or equal one dash dash. Obviously that's not an employee. And I just put in a random text for the, what they call the authentication TAN. And when I did that, it gave me a list of all the users in the database. Now, this is not unique to WebGoat. I have done this effectively exact same thing in multiple applications, and it gives me the entire user list. It seems kind of odd. Why does that particular phrase, Smith quote or equal one dash dash, dump the database for me? Yep, just like that. Um, like I said, this is called an injection attack, and this is one of the reasons you need to understand how coding and protocols work, because that's how you figure out how this SQL injection attack works. Oh, and by the way, I'm sorry if you're a NoSQL sort of person, you still have the same problems in a NoSQL database as well. It's just a slightly different attack. And it doesn't matter what version of SQL you're using, whether you're using Microsoft's or you're using Oracle's or you're using, Postgres or MySQL, they all have the same problem. And what it really boils down to is, I'm hoping everybody can see my mouse here, but the very first thing, it has this, funky looking thing, and that's how programmers put stuff together. They build things out of other pieces. And when you get yourself your normal data, it's, where last name is Smith and, the authentication TAN is that number. It goes out into the database and pulls that information. And it just pulls a single one because you should only have one Smith with that particular authorization. But if you use this specially crafted phrase that I've been using, Smith isn't that important. You could use Smith or Sternberg or Harry or Ralph or whatever you want. It's the last two pieces that are important. The or one equal one tells the SQL program or the database that everything is true. And I'll explain why that's important here in a second. The dash dash is a SQL comment that just says ignore everything after the dash dash. So you put that all together, and what you end up with is select everything from employees where everything is true. So it gives you the entire list of the employees. And again, this is why you have to know programming languages, so can you understand how these quirks and stuff work. Now, it's really easy to avoid these, especially SQL injection attacks. Pretty much every modern language that you could mention has ways around it, has things you can do to prevent it. So why is this one of the more common ones out there? Is it because developers are lazy? Is it because they're dumb? Well, no, that's actually not the reason. You may occasionally find a developer out there who is unfamiliar with this, doesn't know how to do it in their particular language. But the reason these things are so frequent has very little to do with the actual developer, but we'll get into that later. Let's see. Okay. I'm being abused here on the Discord channel. Anyway, the second one is broken authentication. Um, Basically, it's not properly validating the user. One of my favorite areas of broken authentication are those security questions. What's your mother's maiden name? What school did you go to? Stuff like that. Because all you need is a little bit of OS int and you can figure it out. Story time. I was actually poking around on a school site. It won't say which school either. And I noticed that it had these security questions. Well, I happen to know the email address of the HR person because I had actually applied for a job there. And just out of curiosity, I tried to log in as her, and it came up and had a couple of questions there, like mother's maiden name, what's your favorite color, that sort of stuff. And since I was kind of bored at the time, I went over to Facebook and I did a little research on this person. And sure enough, there was her mother and her mother's name and her mother's maiden name. She had posts in there about what her favorite colors were, stuff like that. Okay, just out of curiosity, I typed that in. Sure enough, the program let me in. I had access to her account. Because they set it up improperly, even though she was only in HR, she had admin privileges. So I was able to wander around on pretty much any computer I wanted to. This sort of made me nervous because I was just sort of doing this as a lark. So I reached out to the school. I let them know this sort of stuff. But, security questions are completely useless when it comes to authentication. The other one you run into is, we all know passwords are bad. Passwords are easy ways to get in, but sometimes it's hard to convince projects of this. So here's a little nmap command that does a brute force password attack, against a particular machine and port. Another story. I had a project that rejected my claim that they needed to enforce a password policy. So I ran this and then demonstrated to them that out of the 3 or 4 thousand accounts they had there, I could get into something like 500 of them because they used passwords like password one, football team, Broncos, that sort of stuff. So they realized that was a good idea, changed their password policy. Then I ran it again and demonstrated to them that I could do a brute force attack and nobody would notice me because they didn't have any thresholds set up. So then they did that. So then I ran it a third time and demonstrated to them why you needed to use multi-factor authentication, because it didn't matter how good or how complex your passwords were. If I used a particularly powerful enough machine, I could spend the time, figure out what the password was and get in that way. So it took 3 times, but eventually I convinced them that they needed to use multi-factor authentication. The third one is sensitive data exposure. This is basically showing things to the user or the hacker that you really shouldn't show them. Now, what you're seeing here on the right, well, you got the login screen for WebGoat, but on the right, you're seeing the result of something called Burp Suite. Burp Suite is probably one of the more useful tools for application hacking. And what Burp Suite does is it sort of gets between the user, i.e. the login page for WebGoat, and the server in the back end. And for those of you that are unfamiliar with the machine in the middle, that's effectively what it looks like. I'm intercepting what the WebGoat is sending to the server. And what it's sending is this HTTP post request. There's lots of interesting information in here. Again, if you do application hacking, you'll learn about all this stuff. The important things are things like the session IDs for the cookies. Um, Go up here, the origin can be played with. I have examples of that. We actually won't go through it today, but it's at the end of the slide deck here where you can play with the origin header. If you get a hold of the session cookie, you can do replay attacks. You can pretend to be somebody else and do things under their account, really neat things like that. But the important thing here is you'll notice, oops, went a little too far. There we are. Down here on the bottom, username is WebGoat and the password is WebGoat in plain text. They didn't even bother to encrypt it. So that's an example of showing things that you really shouldn't be showing. By the way, if you happen to be using FTP, by default, FTP sends passwords in plain text, which is why you shouldn't be using FTP. XML External Entities. I keep warning you need to learn programming languages. XML is one of them. Although a lot of places use JSON now, JSON also has weaknesses as well. I just happen to be using XML here because it was easier. So here is another WebGoat page, and it's sort of like a Discord type channel. And then over here, if I type in junk, I press submit. This is what is sent from the client to the server. And you'll notice, it says it's XML, it's got a comment, the comment's text, looks fairly innocuous. The other thing you can do in Burp Suite, which makes Burp Suite very useful, is you can change it. So what I did is I went in and I stuck in this doc type user root system file thing. And basically what it does is it runs this HTTP command as a system instead of actually typing in the word junk, because I took junk out. Now, if you do this and then you continue sending it to the server, what the server will happily give you is the root file system of the computer I'm actually running on, because it didn't validate this XML information. And far too many programs have that same problem as well. So that's one of those things that if you see it has XML on it, you can, try this sort of attack and see if it lets you in. Okay, let's see, any questions? Nope, still more hassling. And I warned you at the very beginning, I have squirrel moments, and here is a squirrel moment. I've been talking about application hacking, and the thing that's important for you as the hacker is to figure out why you're doing it. Hacking, quite frankly, can be, if you don't have permission to do it, technically it's wrong, illegal, and dangerous. There, I've said it. But the thing is hacking can also be a good thing. Now, I will freely admit in my adventures in hacking, and I am by no means a professional hacker. I am not a red teamer. I'm probably closer to a blue teamer. I've seen interesting things. Ran into a place where they kept pictures. People didn't actually realize their pictures were being copied and uploaded to this S3 bucket. We'll just say there are people who take pictures of things that they really shouldn't be taking pictures of. Very disturbing, and I have been psychically scarred for life. But probably my favorite story is a number of years ago when people started hacking video cameras. I ran a Shodan, and I'll explain what Shodan is in here a little bit. And I just kind of poked around, and I got to watch a video camera in Russia where they were building something, and that was kind of neat. And saw another video camera where they were, there was, as far as I could tell, they were watching a trash can. Seemed a little weird to me. Why would you watch your trash can? But whatever. And then as I happened to find a video camera that was, into somebody's house, and I was able to rotate the camera, and I'm like, ooh, I can rotate the camera. This is neat. And there was a couple sitting there and they were watching TV. So I rotated the camera and I was watching TV, Spider-Man 3, ironically enough, with them. And it occurred to me that's a little bit disturbing. Here I am hacked into somebody's house watching their TV shows. So, it can be a little bit interesting. But on a more serious note, uh, frequently what I'll get is I'll get somebody will reach out to me, or they'll go through, the appropriate channels in the company, and they'll say, I broke into your web application. Here's the stupid stuff that you did, kind of nanny, nanny, nanny sort of a thing. That will not go over well. Now, if you're a developer, you've spent weeks, months, possibly even years working on these programs. You've devoted a lot of time and effort, and having somebody, basically do a nanny, 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 I broke in, you're not going to react well to that. And frankly, that's even assuming you even find out about it. Because when you go through some of these things, you reach out to the security team, or at least the email that has the security team in it, you may not actually be reaching any of the developers. This may go directly to the legal department, and the legal department will send you a cease and desist message. Yes, I've had a couple of them, and it never even gets to the developers. So, you kind of have to be careful about this sort of stuff. Yeah, you might find a vulnerability, but that doesn't necessarily mean anyone's actually ever going to get to fix it. Now, if you're a defender out there, why do I care about hacking as a defender? Other than the obvious thing, somebody got in. Quite frankly, if you don't know how they got in and you can't duplicate it, how are you going to fix it? So this is one reason that I tend to get really, and I probably have talked longer on this subject than I needed to. I get really excited about the whole concept of red team do red team, blue team do blue team, because I think it's a wasteful and bad separation. But you know, sorry, you're getting my opinions here. What can I say? But it boils down to one thing: if you do hack, try not to do evil. So back to your regularly scheduled program. The fifth one is broken access control. Basically, what this means is the assumption is if the user is able to log in, then that means the user can do anything. Well, here's one way to check to see if that flaw is in a program. So here we have a URL, and it happens to go to this particular SQL injection page for WebGoat. Well, I went in and I modified it to go to a different web page, and it let me, no problems at all. So you might be asking yourself, well, this is WebGoat. You're supposed to be able to look at all these lessons. What's the big deal? Why would I care about being able to modify a URL? Well, what if the URL was a medical system and it was doing something like showing you patient records? Um, this actually is a real life example. Everything's been changed to protect the guilty. And this is how the developers went and got my medical records. I took a look at this and I noticed that my medical records were, interestingly enough, sequential. It was page number, 1, 2, 3, 4, 5. The next one was 1, 2, 3, 4, 5, 6. And then it was, so there was this nice sequential thing in there. So just out of curiosity, I put in a number that didn't belong to me, and sure enough, I was able to pull up somebody else's medical records. The other thing you can do with that information is, if you notice it's sequential, is you can put in a little loop, because fetching these patient records takes time, takes resources. So you can quite easily overload a server doing this and have quite a nice little denial of service attack. Well, I guess it's nice for you, probably not so nice for the medical system. And again, this is one of those sorts of things that when I stumbled across it, it was in my own medical records. And, I sent this to I actually happen to know who the developers were, so I went directly to them. And I said, hey, I ran across these sorts of things. The simplest thing to do is don't use sequential page numbers. Oh, sorry, I'm not supposed to get into fixing this. The next one is security misconfigurations. I view this as it's when you lock the door, but leave the window open. Cloud environments. Now I'm going to pick on AWS here, basically because the last job, AWS is what they used. But Azure has the problem, Google Cloud has the same problems, and, and a lot of it boils down to one, not understanding your security configurations, and then two, your boss comes in and says, okay, you need to migrate this up to the cloud. You have 2 weeks to do it. Okay, you're not really going to spend a whole lot of time figuring out how all this stuff works. You're just going to try to get it up there as fast as possible. So what we have here is it's an AWS command line program, and I'm telling it to look at all the S3 buckets or excuse me, use the S3 commands. LS, for those of you that are in Linux, know what LS is. If you're not Linux, LS is the same thing as a directory listing. And, here's a bucket name. And I actually tested this on my AWS buckets. And sure enough, it came up and said, okay, here's everything in the bucket, which is perfectly good because I had logged in as myself. Well, then I tried it on a couple of other buckets and I was able to take a look at those, even though they were, shall we say, not my buckets. And it came back and said, okay, here's the name of the bucket, here's the files on it, here's the size. There's actually a lot more information that comes back with this that I'm not putting in here. Well, okay, I'm suspect that, Joe Company probably didn't want me to take a look at their S3 buckets. What is it that they did wrong? Now, the typical thing is there is a user, excuse me, a role, there we are, a role called authenticated user. Most developers look at this and say, ooh, authenticated user means that somebody's logged into our AWS account and they're an authenticated user for our AWS account. Well, that's not what that means. What that means is I have logged in as an AWS user, not for the company, but any AWS. This is a fairly common one. Most of the time you get an authenticated user, you do start listing bucket names, and in the documentation or in the notes here, I have some ways of getting bucket names if you don't happen to know it. And you can pull all this information out. And it's because things were misconfigured, the developer didn't have the time to figure it out, and quite frankly, the AWS documentation, while it's very voluminous, is not particularly good in some situations, and describing this was one of them. Cross-site scripting. This is another really fun one that you as an application security hacker can, just have way too much entertainment with. You'll notice that there is a little pop-up here that says Fred. Okay, that's very exciting. You go down a little further and you see I put in this JavaScript command, script alert script, into an actual entry field. The entry field is supposed to be a series of numbers. Obviously, the field wasn't being validated. But why the heck did it run the JavaScript code? Well, that's because what this is this code is sent to, excuse me, this code is sent to the browser. The browser is what actually invokes this command, not the server and not the client. So it sort of steps outside of the client server boundary, if you will, and actually executes the Java code. Now there's three different types of cross-site scripting. There's reflected, which is what this is. There's stored, and there's DOM, document object model. Again, more information in the slide decks, which we won't go over today. Now, of course, as an attacker, you're not going to use alert. You're going to dig through the HTML form and you're going to look for something like this, where they're putting parameters directly into a value. Then you're going to modify that parameter and, you might do something like, document cookie. And so you do that, and that information gets sent back to your website, and you have the cookie that's part of the web page. You know, uh, why is that useful? And again, session IDs are used in replay attacks. You can log in using a cookie. You can log in and pretend to be somebody else. One of the common things that cross-site scripting is used for are like on um, pages where you buy things, shopping carts, stuff like that. You get somebody's session ID and you basically can be them. You can purchase stuff under their account. You can use their credit card, and they won't know a thing about it until they get a bill. So, cross-site scripting is one of the more dangerous ones out there because you can literally do anything in the uh, script that you can do in JavaScript. And since JavaScript is an entire program, you have access to literally an entire programming language where you can run anything you want. Insecure deserialization. That sounds like a really impressive one. Basically what it is uh, serialization is the process of taking an object in memory as the program is running and you save it onto disk. It's sort of like taking a snapshot of the program. You can think of it that way. And then later on, the program will load up that snapshot and take off from where it was left off. A great time saver, useful for things like I want to, stop the program here and then come back to it at a later date. And I wanted to pick up wherever I left off. So very typical use case. And but the problem is you can go in and you can change that binary data. There's one example here how you can change it in a Java program. I won't step through how this Java program works, but what it ends up doing is it's a very nasty denial of service because this is in effect an infinite loop. So your program will happily try to read this. It will continue reading. It will use up all memory. It will probably, start writing stuff to disk, possibly using everything up on your disk, which is not good in a Linux system to say the least. So horribly bad things happen. We'll just put it that way. Well, for those of you that are programmers, you may be looking at this and go, nobody uses Java. Java's a bad code. We don't use Java. We'll use something safe like YAML. Well, bad news. You can do the same thing with YAML. Just as a side note, you'll see most of the time that I might pick on a particular language, whether it's Java or SQL or pretty much anything out there. All languages have these issues. I don't care whether you're using Python or Ruby or assembly or C or, insert language here. They all have their issues. Different issues, but they all have issues. So the fact that I have an example here in Java is solely because that's what I happen to have. Given enough time, I could come up with one in, pick your language. So like I said, here's your safe language YAML. You can do the same thing. The problem with this particular YAML code is this thing here, load. Load will take whatever as it's told to and happily load and run it. A year, maybe 2 years ago, YAML realized that was probably a bad thing, and they changed it to YAML or safe underscore YAML, which is what you're supposed to be using. That's great. So anyone that's aware of that, who's writing new code, probably is immune to this. However, there's thousands, if not millions of lines of YAML code out there that hasn't been updated, hasn't been fixed, and suffers from this exact same problem. If you think back to one of the earlier screens I had, as an application hacker, you have more real estate that you can go after than you can possibly imagine. And I haven't even gotten into the whole IoT thing and the fact that IoT tends to use very old and very antiquated code, doesn't keep it up to date. So yeah, there's just so much to aim for in the application security field. You could easily spend your life and only hit just a small portion of it. As a side note, these deserializations are also frequently used by crypto miners because what they'll do is they'll sort of add their binary code to the end of the deserialization code. So your stuff comes up, runs perfectly. You don't notice anything because it acts just like it is supposed to. But in the background, a thread or another process has been started up and it's happily doing crypto mining. So, that's something you have to also be careful about. And again, in the slide deck, I have some examples of where that's has been used before. Using components with known vulnerabilities. I sort of alluded to this in some previous discussions, but the things don't get changed frequently in the programming world, or they get changed very frequently in the programming world. Sort of depends on which side you're looking at. We're all familiar with open source. As a developer, open source is great. I can get this open source. I can, save myself all sorts of time and effort, and get things done at a faster rate. Just as to give you an idea of the scope of this concept of open source, I got a little blurb here. A company called Black Duck, which scans open source components and stuff. They looked at 1,100 commercial code bases. This was back in 2017, so that's 3-4 years old now. And they discovered that 96% of the applications they scanned had open source components. And of those 96%, the average was 257 components or pieces of open source for each application. So just sort of think of that from a scope standpoint. 96% of the programs you run into have 250 open source components. I can pretty much guarantee you the 250 open source components are not kept up to date. Some of them will have vulnerabilities in them. Some are no longer maintained. Some of them, the developers have gone on to bigger and better things. So, it's just code that's been out there. I mean, I've seen code as old as, the 90s that's still running inside of programs. Again, a great, a big area for you to attack. A great example of not keeping things up to date is the whole Equifax mess. I'm sure I'm sure most everybody here is familiar with Equifax. Just in case you're not, it happened in 2017. And because they were using Apache struts and there was a particular vulnerability out there that they didn't get patched, somebody or someone or China or take your pick who you think it was, they got the private records for 148 million Americans, 15 million British citizens, and 19,000 Canadian citizens. Quite the impact, to say the least. And this was because somebody didn't keep their Apache struts up to date. Now, there's lots of discussions as to whose fault it was and all this sort of thing, which we're not going to get into here. This is just an example to show you that, even in the biggest of companies, things don't get kept up to date. Now, if you've heard of the Heartbleed vulnerability, this was maybe 3, 4, 5 years ago, something like that. It was very nasty vulnerability, actually, that was found in some open source code known as OpenSSL. 5 years later, 6 years later, if you run the Shodan's list of devices, you'll find a bunch of them that are still vulnerable to Heartbleed. Now, for those of you that are unfamiliar with Shodan, it's a search engine that basically goes out and scans webcams, routers, servers, programs, everything. And you can search for various things. In this one in specific, it's searching for Heartbleed vulnerabilities. You can say search for web cameras in the US that are made by, a Chinese company. So, you can get very specific and it'll give you a list of all this stuff. Now, I sort of talked about this a little earlier, and a lot of people take a look at or hear these sorts of things, and they think, well, the problem is lazy developers. Developers aren't keeping things up to date. It's all the developer's fault. Well, I'm a developer. I sort of take offense at that, but in reality, even updating something like Apache Struts, which is a fairly well-known application. Let's say you find that an application that or an open source component that you're using is no longer maintained. Somebody has to write it. Let's say you do update, you do keep everything up to date. It's not unusual that you will update something to a new version and your program stops working, your program breaks. So then you have to stop your development. You have to stop getting things done in order to fix it. The example I've used before when describing this to people that think it's all programmers' fault is how would you react if you got a message saying, okay, the light went out on your refrigerator, so we've turned your refrigerator off until a manufacturer ships us a replacement part. Should come in the next couple of weeks, or maybe you might have to buy another refrigerator. Yeah, that's pretty much the same thing as going to a company and saying, you have this code that needs to be updated, so you should stop everything you're doing and update it. It just doesn't work in the real world. Is this a problem? Yes. Is it something that needs to be addressed? Yes. Is it something I have a solution for and I'm going to tell you about right now? No, because unfortunately it's a common issue. But the key thing here is that I'm trying to, in my poor way to point out here, is this isn't a blame game. Because you found a problem in a program doesn't mean the program's bad. It doesn't mean that the development group is lazy. What it means is that this sort of stuff needs to be given to the developers and the architects so that they can come up with a good way or a clean way of updating and fixing their program. So with that public service message, we'll continue on here. This is probably my all-time favorite picture. I don't know how well it's going to come across on the Twitch screen since I don't have Twitch up and running at this point. But if you look down at the very bottom of this picture, you'll see that there's a pair of shoes here. And if you look real carefully, you'll see somebody is wearing some sort of clothes or a cloak that lets them almost perfectly blend in with the background. This is what you as an application hacker really want to do as well. You want to blend into the program. You want to blend into the system. And this is an area that developers tend to overlook. They'll write logs, they'll write monitoring stuff, but they won't necessarily make them or protect them. So you can get in and you can, delete the fact that you got into the system. You can find some interesting information. I've seen logs where passwords were put in just as part of the normal, development process because the developer wanted to be able to reproduce an error if it happened. You can see session IDs. A lot of times a developer will simply dump the contents of an HTTP request, which will include session IDs. And, as you saw earlier that with the OpenGoat, it might even have an encrypted passwords in it, stuff like that. Okay, I'm doing this for a good purpose. Why would I want to disguise myself? Well, part of the reason that you're disguising yourself is to make sure that the monitoring software can catch you. They say that the typical time to detect a breach is 200 days. That's scary to say the least. So you sort of want to, when you're helping out a team, when you're doing your penetration testing, when you're doing your red team engagement, when you as a developer are poking around, testing out your program, or if you're a security guy, helping out the development team, you want to try to get that monitoring, that detection down as quick as possible. Just imagine what a professional malware hacker can do in 200 days. So that's sort of the interesting thing with that one. And that's where logs can be very important, because these logs are absorbed and read in by security operations centers, by monitoring programs. They're evaluated by machine learning and all this sort of stuff, and they're supposed to catch this sort of stuff. I can't even begin to tell you how many programs I've done pseudo penetration tests on, even just the brute force stuff, like that example I had earlier in the presentation, where I was doing brute force attacks. I was literally sending thousands and thousands of password requests, a minute or a second, and no alarms were going off. That's an indication that, I'm sorry, something wrong was set up in your system. Those sorts of quite obvious red team efforts should be caught immediately, but frequently they aren't. So at any rate, that is pretty much my time. I'm actually on time, which is very unusual for me. So, this is time for question and answers if you've got any. Here's some information if you want to reach out to me. Like I said, I'm happy to send the slide deck, which has got a lot more information in it. If you want to reach out and ask me questions, that's fine too. And with that, I will turn it over to the moderator.
Okay, thank you very much, Greg. So as he said, if you have any questions, you can jump in the Discord, check the B-Sides Denver Twitter for all the links throughout the day. We're using different Discords for different speakers, just for, isolation, keep one of these hooligans away from the other, that kind of thing. We got about 15 minutes. It's quite a bit of time, plenty for questions. They don't have to be about the talk. You can also ask them other inappropriate questions, or you can ask telecom, tales from back in the day, which goes back quite a ways. I mean, really.
Yeah, I'll respond to a couple of these things here. And no, it's not ask for forgiveness instead of permission. Let's see here. Now, somebody else, when we were talking about security questions, they made a very, very good comment here about, you don't actually have to answer the security questions correctly. The company isn't going to go out and make sure that you use the correct mother's maiden name. So a lot of people will just stick in random information there. That's certainly a one way of handling those security questions. If you type in, 45 characters of random garbage, chances are I'm not going to figure that out very well. I have, however, seen situations where they will actually do basically brute force guessing on some of this stuff. I wouldn't be surprised if at some point they're going to start, just doing random characters, sort of like password spraying, if you will. I suspect that most of those question and or security questions aren't well monitored. So would not surprise me if people start doing that sort of stuff, because like I said, I doubt they're monitored. I doubt there's any thresholds associated with them. But that's actually a very good way to handle those security questions, is don't put in the real answers. Let's see here. Looking through. Yeah, a lot of hassling on this. Okay. I think those were all the
There's a question at the end there for you.
If I had to do everything to do over again, what would I do differently from a programming standpoint? That's actually a very good question. it's hard to say. One of the examples I've used is, you know, decades ago when I wrote programs, I wrote programs that had SQL injection attacks in them. And as a matter of fact, some of the code that I showed in that um, page there, or in that slide there, looked exactly like code I wrote, 20 some years ago. That's part of the problem with the whole development cycle. And it's even worse for things like shuttle, code that, runs on the shuttle, or code that's, in an embedded system. Because, you write these sort of things and you may write it as, secure and as tightly as is possible for the time. But you put it into your chip, you take your chip, you stick it into a car, you embed it in your microwave, and 2 days later, somebody figures out a way around it. They figure out that 1 = 1, that can be stuck in there. So now all of a sudden, your code is vulnerable. Well, what do? I mean, you can't wander around to everybody's microwave and replace their chip. If it's an embedded device, you usually can't update it. So what do? This is a common problem in the development arena, and there's no good answer for it. You hear some people talking about how, well, 5G will solve those because your microwave can now be connected to the internet, ignoring all the conspiracy theories with 5G at this point. Well, if you connect it to the internet, you have all sorts of other issues. When one of the Chris's talks later today, you can always ask about the dancing Roombas, which is one of my favorite stories. Because if you connect something to the internet that wasn't originally connected to the internet, I can almost guarantee you it wasn't written securely. So yeah, you can connect all this stuff to the internet, and now all of a sudden you have trillions of programs that are all vulnerable. So that's not a good solution either. Let's see here. Actually, I don't actually know of any good books or online. Actually, no, I take that back. The best online reference, I can't think of any books off the top of my head, but the best online reference would be OWASP.org. They probably even have books there. It is a great place to learn everything there is to know about application security, whether hacking it, whether defending it. Really, that's the place I would start. Once you do that, then it's just a matter of learning various, things involving with programs. HTML and JavaScript are great places to start to learn things about, how your web systems work, how your application programs work. Oodles of online examples. I've got some of them in the slide deck as well. W3C Schools is a great place to learn. There's hundreds of YouTube videos out there that basically go into that, they step through WebGoat, for example. Here's how you break into the WebGoat stuff. There's things out there that'll teach you all sorts of programming code. I mean, at this point, you probably don't even need books anymore. You can probably just do it all online. Let's see, next question. That's actually a very good one. Which is more rewarding, attacking software or protecting software? I'd say it's a faster thrill to attack software, but it's probably more of a satisfying thrill to keep them out. But that's me personally. Some people prefer the hacking to the protecting. Some people prefer protecting to hacking. I like to do both. Let's see here. Yep, good point there, Doug. SANS has some great resources as well. But yeah, like I said, SANS, OWASP, those are probably your top things to learn about all things application. And like I said, you just go into YouTube, search for application hacking, web attacks, stuff like that. And there are people there who are literally typing it in, and you can watch them do it. You know, great place to learn all that sort of stuff. Like I said, at best, this was just sort of designed to pique your interest, but there are plenty of resources out there. Let's see here. Yeah, well, for those who are thinking, I will say that I started my career, my official career, as a coder. You know, I have done programming and coding for an extremely long time, and I sort of learned security sort of by accident. It was one of those sorts of things where, you know, it's like, well, what if somebody does this? Or, you know, why isn't there a username password around this? Or why are you sending it in, you know, plain text? And that just sort of naturally led into the whole security arena. Now, if you go far enough back, I actually technically started my career as hacking. I'll give you an idea of my age here, hacking floppy disks on an Apple II. So that kind of gives you an idea of just how old I am here. But
That sounds familiar. By the way, Greg, 5-minute warning.
5-minute warning. Okie dokie. So, and frankly, a diverse background helps a lot when it comes to hacking. If all you do is think like a programmer, you'll fall into the same mindset that programmers do. So yeah, if you come from a religious background, you come from an embedded background, you come from networking. I mean, heck, you come in as a teacher, you will see things in a different light than the developer did. And frankly, that's great because you will see things that the developers will miss. So with that, yep, the Humble Bumble books are a great place to get that sort of stuff as well. And with that, I think I've hit all the questions that are coming in at this point.
Yep,
I will be
we're going to kick you
monitoring
out
the
at this
Discord
point.
channel. So if you want to type in something afterwards, that's fine too. And with that, I be finis.